Hello, in this video I'm going to be showing you how to find the area of a sector and the length of an arc when dealing with radians. So I'll start off by showing you the formulae for these two things, and then we'll look at three different examples of varying difficulties, and I'll timestamp those below. If this video is useful, please do go over to my channel where you can see all of my other maths tutorials, and I'll also link my website in the video description so you can navigate all of my videos in one place. I think it's a bit easier to do it over there than it is on YouTube. Thanks for watching. So to start off with, we're going to look at where the formulae for finding the arc length and the area of a sector come from. And to do that, we're going to take a look at this circle that I've got drawn here. Now, I already have a radius labelled on, but what I'm going to do is add on another one. So let's draw on another radius here. Now you can see by having these two radii, what I've done is kind of take a piece of the circle, I've kind of cut out a slice of it. And I'm going to shade in the slice that I've cut out, this one here. Now we call this slice of the circle a sector. Okay, so I've created a sector, and sometimes we might want to know what the area of this sector is. And to find this is actually quite straightforward, and in fact you may have done this back at GCSE. Now between these two radii that I have, there's going to be some angle. Now I don't know what this angle is, but I'm going to call it theta radians. Remember, we're working in radians in this video. So we could say that the area of the sector, well, that's going to equal, well, imagine we had the whole circle, which would be pi multiplied by the radius squared. Now this sector is just some fraction of the total circle, isn't it? And so the question is, well, what fraction of the circle is that shaded sector that I've got? Well, let's think. In a full turn around the circle, that would be 2 pi radians, wouldn't it? And so what fraction of the total circle is this sector? Well, out of those 2 pi radians, it's theta radians. And so I could multiply the total area of the circle by the fraction of the circle I have, which is going to be theta out of 2 pi radians. Now this is going to simplify, because if we take a look at what we've got, let me write it all out as one single thing. It's going to be pi r squared multiplied by theta, all divided by 2 pi. And hopefully you can see these pi's are going to cancel out on the numerator and the denominator, and I could rewrite this as 1/2 multiplied by the radius squared multiplied by the angle theta in radians. And this is our formula for the area of a sector, only when we're working in radians. So if you're dealing with degrees, this formula won't work. It's only going to work when we're in radians. So we get rid of this working out, and I'll put this back up to the top. So this is our first formula we're going to use. The next thing we want to be able to do is find the length of an arc. So you can see these two radii that I've drawn on, let me highlight them. These have kind of cut the circumference of the circle into two pieces. This small one here, and this slightly larger part of the circumference here. So say I wanted to find the length of this arc that I'll kind of highlight on in red, and I'll call it length L. How could I do that? So the length of the arc is going to be given by, well, we could take the full circumference of the circle, which is 2 times pi times the radius, and again we could multiply it by the fraction of the circle we have, which is also going to be, well, theta out of 2 pi radians. Now let's again see if this simplifies. Well, it's going to be 2 times pi times the radius times theta, all over 2 pi. And you can see these 2's cancel out, and so do these pi's, and so actually I get left with a really nice formula. It's just r times theta, so the radius times by theta. And that's going to give us the length of our arc, so I'll get rid of this working out too. And these are the two formulae that we're going to use in this video. I'll kind of put them in a bubble like this. And it's good to kind of remember what these formulae are. So let's bring them down, and we'll take a look at a question. There's 3 questions we're going to look at. So the first one says calculate the arc length of the following sector. So you can see here we've been given the radius, the angle, and we're missing the arc length. And I'll call the arc length L. That's usually the letter I like to use for it. So we need to find L. Well, the length of an arc, L, is equal to the radius of the sector multiplied by the angle in radians. So it's going to be 3 multiplied by pi over 8. And so I suppose if I wanted to leave the answer exact, I could leave it as 3 over 8 times pi centimeters. Or to 3 significant figures, the length of this arc is going to be 1.18 centimeters. And that's it. So you can see it's pretty straightforward to use. So let's now bring down our formulas and take a look at the next question. So it says find the missing angle theta in the sector below, then calculate its area. Now we have the radius of this sector as well as the arc length. What I could do is use my arc length formula and then rearrange this to get the missing angle theta. because I know the length of the arc, which in this case is 3 centimeters, is equal to, well, the radius, which is 8, multiplied by the angle theta. If I divide both sides by 8, I get 3 over 8 is equal to the angle theta in radians. So now then I could rub this off and I could say, well, I know this angle is 3 over 8 radians, and using this I could now calculate the area of the sector, because I know the area, let me use a different colour, the area is 1/2 multiplied by the radius squared, so multiplied by 8 squared, multiplied by the angle in radians, which I now know is 3 over 8. And so I could calculate this and I would get the area is 12 centimeters squared. So let's bring down our formulae and have a look at the final question, which is a bit trickier because there's multiple steps. So it says, given A and B are sectors of circles and OX is a straight line, calculate the area of sector B. Now sector B has been highlighted in red, hopefully you can see that here. Now looking at our formula for the area of a sector, there are a few things we're going to need to find out to do this. We're going to need to know the radius of this sector as well as the angle of the sector. And so to do this we're going to have to do a bit of problem solving. So let's start off by say finding this missing angle here. And to do that I could say, well, angles on a straight line add up to 180 degrees, or as we're working in radians, add up to pi radians. And so that must mean, if I annotate it on this angle here, which I'll call theta, if I add it on to pi over 4, it must equal pi because it's on a straight line. And so we get pi over 4 plus theta must equal pi radians, which then tells me that this missing angle theta, if I subtract pi over 4 from both sides, is 3 over 4 pi radians. So that's the first piece done. The next thing we need to do is find the radius of this sector. And to do this, what I could do is find the radius of the sector where I have more information, and then use the fact that this total length is 8 to find the difference, which would leave me with the radius. So let's do that. So let's start off by finding the radius of the sector here. Well, I know that the arc length, which in this case is 3, is equal to the radius, which I don't know, multiplied by the angle, which is pi over 4. Let's divide both sides by pi over 4, and to 3 significant figures, this tells me the radius is 3.82 centimeters. So there's the radius there. So I could now annotate this on. The radius of this line here is 3.82. You can see it's not really to any scale, this diagram. What I can do now is subtract 3.82 from 8, and this remaining distance will be the radius of the sector I'm interested in. So let's do that. So that's going to be 8 subtract 3.82, and that's going to give me 4.18 centimeters. So let's annotate that on 2. Let me use a different color so it's a bit clearer to see what's going on. This radius here is going to be 4.18 centimeters. Now I think I have all the information I need to find the area of sector B, because the area of sector B is going to be equal to 1/2 multiplied by the radius squared, which is 4.18, multiplied by the angle, which is 3 over 4 pi. And if I type this in my calculator to 3 significant figures, I get 20.6 centimeters squared. So you can see really this picture was not to scale at all. So hopefully this video was useful. If it was, please do go over to my channel where I have loads of other maths tutorials, and I'll also link my website in the video description so you can go over there and check out all of my videos in one place, and it's kind of a bit easier to navigate them. Thanks for watching.